Okay, go ahead and get started. So today's webinar is called Coreform Cubit, Strategies for Solving Tricky Mesh Problems. And so I'm one of your hosts, Matt Cederberg. I'm the CEO at Coreform. Greg Vernon, the Director of Product Management at Coreform, will be presenting as well today. And just a little bit about Coreform. So we're notified that we're the fastest growing CAE company on the Inc. 5000 again this year. We were established in 2016 and acquired the Cubit software in 2019. And we're headquartered in Orem, Utah, but we've since gone remote with lots of employees elsewhere since COVID hit. At Coreform, we're developing software to improve simulation through better geometry. So we have two software products, one Coreform Cubit that's used across industries for advanced meshing for all sorts of challenging simulations, and Coreform IGA, which is our new revolutionary IC geometric analysis solver. But today we're going to be focused on Coreform Cubit. And as many of you may know, this is more of an intermediate focused webinar. We assume many of you are already familiar with Cubit and using it for CAD cleanup and semi-automated and automated hex meshing and TEP meshing. A lot of you may be using it for Python and scripting. If you're not yet, we have other webinars that focus on that. But today, we thought we would do something new for our webinars. If you're aware, if you've been to other webinars, we do these about every month. And also, we've noticed a big increase in questions over the last while in the Coreform online forum. And we thought it would be fun to just answer live some of the questions that have been coming that we think are kind of interesting. So we solicited responses, and the three questions we're going to talk about today are how to mesh STL files, how to disassociate meshes for faster performance in Coreform Cubit, and then also introduce some useful command line only options and show you how to use those to enhance and get more power to your modeling workflow. We'll also have additional time for Q&A. So if you have some questions that you've been wanting to ask in our forum or that have just come up, we will certainly have some time at the end where we can answer your questions live. And if you do have more questions that come after the webinar, again, feel free to go to our website. We have a lot of training material there. Again, you can post them on the forum, go through training classes, and catch recorded webinars. A lot of these are also posted on our YouTube channel. So with that, let me turn the time over to Greg Vernon. Again, he's the Director of Product Management at Coreform, and he has used Cubit professionally for over 8 years prior to coming to Coreform. And so let me turn the time over to Greg.
Thanks, Matt. Yeah, so wanted to show or share today, there have been some questions that have come up with several of our customers around kind of facet-based CAD models, like the STL file, which are becoming a bit more common and prevalent today with 3D printing and a lot of animation, it's like computer game sorts of things that many of our customers are seeing more or less of the step and like SolidWorks and NX types of files and more of these STL or facet-based or triangle-based kind of files. So what I want to show today is a couple options you have for meshing these models in Cubit. So I'm going to show you today is a heart. So an STL model of a heart. So I've got maybe 3 chambers of this heart. So I'm going to open up just maybe this first chamber. And what you'll see is that there are some options for how to interpret this STL file, which again are linear triangles. And what we do is we can create some sort of geometric representation. I'm just going to leave it as linear. So this is like an organic model that came from computed tomography. And I haven't done much cleanup of the model. I am going to focus mostly on taking the input triangles and just directly meshing them. So to do that, I've clicked this checkbox with the make elements. so that I'll have the triangulation or the triangle mesh of this model. As opposed to just having a facet-based geometry. And we're actually going to do two things here, or show two things. We'll show the disassociating of the triangle. So we've imported this, and what we'll see is that we've got a volume which is independent of the triangle. So if I turn off the mesh view, Cubit has essentially tried to build a facet-based geometry that you could remesh if you wanted with coarser or finer elements. And maybe we'll show the coarser elements in a little bit. But if you wanted just to directly mesh the triangles as is, what we'll do is we're going to disassociate the mesh. So I can show just the mesh, say, from the geometry. So to do that, and I can never spell this, so we have a disassociate.
Greg, while you're
Yeah,
how to spell that, just to be clear, we welcome any questions throughout this. We have a few of our staff online and we can answer them in the back channel, or Greg can, but that's the value of sitting in on this, is a chance to get some intermediate and expert level guidance as Greg walks through this.
Yeah, thanks. I also want to show one thing. You'll see that I've kind of been printing out some keywords and some things into my command line. And when I finally got disassociate started to spell correctly, I was able to get a command syntax. I just want to show you explicitly what I've done to do that. So from having my cursor in the Cubit command line, if I hit the question mark, so if I type in question mark, so on my keyboard, that's shift and then this /, but the key is it's question mark. That will then print this statement here. So if I clear, so I'm completely clear here, and I type this, and I can't remember how to maybe spell it, so I hit shift, question mark, it'll complete the command for me for disassociate. And so later we'll talk about some other keywords like set, and you'll want to see like all of the options we have with set. And again, we'll hit the question mark and it will print out all the commands that could be done with that. So I just wanted to share just how to get kind of that inline or context specific kind of help there. So with that out of the way, I'm going to go ahead and do my disassociate. So disassociate mesh from, and again, I've got volume 1 and it's meshed. So I'm going to disassociate the mesh from volume 1. And what that means I can now do is I can actually delete volume 1. So let me right click here and hit delete on the volume. And I'm left with just the mesh. There is no more geometry. And then from here, with a given input triangulation, we can build a tetrahedral mesh. And so the way I'm going to build this tet mesh is by typing in, there's another command in Cubit to use our tet mesher. So typically our tet mesher operates on volumes. So we might have said, I want to mesh on like volume 1, but I'm going to mesh on these triangles. And that command is just simply tet mesh try all. So it's going to take each triangle and build a tet mesh from within there.
Greg, well, that's building. Robert had a question. What are those ridges on the heart shape?
Yeah, so those ridges were that Cubit was trying to find edges or creases of surfaces. And so it had created lines for that. So it doesn't work as well for organic shapes like a heart. But if we have, let me see if I can find an STL file just on my computer real quick. That's maybe a bit more geometric looking. Oh, we can actually make one. Let's do this. So I'm going to import a step file of, or sorry, and do this. I'm going to import this knuckle here, and I'm just going to go and straight export this out as an STL file. So let's say that for whatever reason you only had access to an STL file. And so if we import this STL file, again, it's a triangulation. And so it'll even maybe show the make elements here so we can see these elements. But this feature angle of 135 degrees is what is going to find creases and give you geometry. So here you can see this STL file that I've imported. Again, I've created elements just so we can see the triangles of the STL file. So it's clearly not like a step file or a Creo file. So I can delete this mesh, and I've got geometry. And so what you'll see is that for this STL file, this fillet doesn't have bounding curves because that wasn't a feature angle, because the angle here is 0. But everywhere else, there's these black curves for these surfaces. And, and that feature angle means that it couldn't find, or it couldn't dissociate or identify that these two surfaces of what we know are two surfaces, it couldn't find those as being separate. So if you wanted to find those, you could just decrease the feature angle and it would find those. But then from here, you could do stuff like decompose this geometry. So you could cut on, say, let's see, on a curve. Let's do, or actually, let's do this. We can cut this volume by sweeping, maybe. We're not going to, be able to sweep that surface. Let's see. We can probably do a loop though. So maybe it can. So facet-based geometry is a little bit more difficult. Typically, if you have facet-based geometry, the best thing to do is to come in and just tet mesh it immediately. But this is where we had that input triangulation that was really coarse. And notice how we can, say, delete the mesh. Let's set a nice mesh size here. It's maybe a bit smaller. And we can actually build a tet mesh on that input triangulation. But it's treating all of those faces as if they're no longer restricted to those triangles. And so you can build meshes that are good for simulation, whereas typically the triangles you get in from an STL file are not meant for simulation. So that's kind of the unique thing here. So if we had this, like these make elements, if we just did tet mesh try all on this volume, you would have built, and then draw tet all. Actually, let's look at the quality of these elements. So you can see I've got tetrahedra that are very thin and long on some of their faces and are really poor elements. And so that's why, taking the input triangulation from an STL file, especially when they're CAD STL files, oftentimes isn't the best way to build your mesh. And that's why what Cubit's done is we've built this, we've taken those triangles so that there are surfaces that bound them. And now it allows us to build whatever mesh we actually want on this volume. So we could build a different mesh with the tet mesher here. It's much higher quality. And we
Okay, so the mesh that you're building is not influenced by the poor
right. Yep.
That came in.
Yep. And so what happened with the heart model is that it tried to find, edges of this organic model. And so it just found like these little peaks. So there are no surfaces in that same sense for this model. So that little tool doesn't work quite as well when you have organic models like this heart. So we built this tet mesh from these triangles. So in this case, the person who had developed this triangle model made sure to create some good triangles of this isosurface of this model. And if we do a cut through the middle, we'll be able to take a look at the tetrahedra that we've created. So let's take a few seconds to render all these tetrahedra.
So while that's rendering, we had another question, just someone came in a bit late. What was the purpose of disassociating the mesh from the volume then, Greg?
Yeah, so the purpose for this case is that if you have a good input triangulation, like this triangulation maybe is good enough, or if it's difficult to build a better triangulation, you can just directly build a tet mesh from those triangles. And so by disassociating, we've kind of just removed this extra geometry that we don't want to muddy maybe the simulation that we're trying to, or these models that we're trying to build just a mesh for. So in cases where the geometry is just too heavy for what you're trying to do, you can disassociate, and that allows you to clear out geometry from your model and just work with the triangulations. And so we find that sometimes is preferable for certain kinds of models, maybe like similar to this heart, for instance, where you're not really going to care about the that input geometry. But I will show why you might care about that input geometry in a little bit. So this is one way that we can build a mesh on this heart. Another way is we go back and re-import the STL model. So let me go over here and do this. I'm going to do this in 2 different spots. Let's import this heart volume again. I'm going to not worry about making elements here. It's going to actually, maybe I'll even turn off the feature angle here. So we showed tetrahedra. Another option that's often desired is to build hexahedra. So again, here are just those black curves that Cubit's kind of found that says, hey, this looks like a surface. What we're gonna do here is we're gonna build hexahedra using our sculpt tool. So sculpt is within this, the mode is volume, or sorry, meshing, mesh volumes, and then parallel sculpt is down here. And we mesh on volumes. So in this case, we have this volume here that we want to build a hex mesh on. You can choose some of these advanced options that we might want to build. And let me make sure I get a good, let's start this with like a cell size of 1. So we can kind of preview this kind of Cartesian-like mesh that's going to be built. So we're going to build a background grid and then take the elements that are inside of the volume and then sculpt them down. And we can mesh this in parallel. So I'm going to use, I've got 8 cores. I'm going to use 6 cores to mesh this with. So while that's running off, let me come back over to this Cubit session and import this heart once again. So in one case with this heart, maybe we wanted to use the input triangulation. In another case, perhaps we want to build our own mesh on this. So what we can actually do, I'll just show a triangle mesh that we can build because we have these surfaces. Let's see, we can build let's go approximate size here of 1 again. And we can remesh the surface with triangles with like that are maybe much coarser than the original tessellation was. And then from those triangles, we could then build a tet mesh. So sculpt is finished. And if we just turn off the geometry here, we can see the hexahedra that are built on this heart model. Cut through and see those hexahedra. Now, what tends to happen with sculpt and similar tools to sculpt is that on the interior, you get really high quality, almost perfect hexahedra elements. Just the nature of the meshing problem is that these kind of Cartesian-based approaches, you will tend to get some skewed elements on surfaces and near the surfaces. So if that's an issue for you, that's something to be aware of. But otherwise, you might expect these hexahedra to be maybe more efficient than some of the tetrahedra. But it is possible that thin regions, the TET mesher will capture those thin regions since it's starting with a known good triangulation, and the hex mesher may not capture those as well. But that's just another way to build this mesh of this heart. And then over here, we can see that I built this triangle mesh. So now we're kind of jumping back and forth a little bit. So I'll maybe try to summarize here in a little bit. But now these triangles are much coarser, except for in those regions where I've got those kind of spiky kind of protrusions. And so if you wanted to have coarser meshes all around, you would need to pre-process this model maybe a little bit more to remove some of these protrusions. Those are not easily fixed in Cubit, but they're easily fixed in STL specific modeling softwares. So just to recap, we showed here how to take an STL file and just directly mesh the triangles of an STL file. We also showed how to take an STL file and remesh it using mesh-based geometry or facet-based geometry, and being able to use our meshing tools here acting on surfaces and volumes. And we did that for this heart model, but also for an STL file of a CAD model. And we've also shown how to build a hex mesh on an input STL file using Sculpt. Those are 3 ways to kind of mesh some of these kind of maybe more tricky models that might come from in your work. So I'm going to pause here and see if there are any other questions that we have for answering.
I think you're good, Greg.
Right. So there's a few other things I wanted to share.
Sorry,
Yeah.
This was one that just barely came in.
Sure.
Is the Sculpt tool the only tool for hex meshing complex organic or molded/casting parts?
A very good question. So for models that come in, especially organic models are very difficult to mesh, just in general. We can mesh them with tetrahedra, but just because we don't have things like planar surfaces, they become just inherently more challenging. While we can do some operations with building hexahedral elements on, say, a well-defined CAD part that that just happens to have been in STL format. When you have organic models, really the only way to build a hex mesh is through either like an overset type of method, like an immersing sort of method, or via Sculpt. And we don't have, it's kind of a combination that it's hard to decompose organic models into logical regions. But yeah, right now in Cubit, the only way to really build like on this heart, the only way to build a hex mesh on this heart is through Sculpt. So yeah, very good question.
Okay, we've got one more now.
Sure.
Was the surface and volume geometry for the heart model obtained separately from the STL file, or was it created in Cubit?
Yeah, the STL file we got that from an open source repository, a public repository that had the STL model itself. So let me open up pair view and I'll show this. Maybe specifically here. It's going to show up in pair view that if I just drag this STL model into pair view. So this model was obtained separately from Cubit. So someone else with some CT scanning software extracted out this isosurface from a CT scan. And so we just directly imported this STL file into Cubit. Now, the green surface that you're seeing, so if I do disassociate mesh here from volume 1, this green model here is a Cubit interpretation of that STL file. And we call this facet-based geometry. It uses a different modeling engine in Cubit. So if we select this volume and go to our property page here, you'll see that under geometry engine, it says facet. And so Cubit has tried to interpret this geometry into something that's, got logical surfaces. But Cubit, just with organic models, doesn't do a great job of identifying what's a surface of an organic feature. It does much better if that model is, say, a CAD-like model. So if I import this knuckle again, it does a better job of recognizing the features in this case. But even this model here, if we click on this, is a facet-based model. So it's based on facets. Whereas the original model, if I import that, the original step or the original CAD model for this knuckle, it's volume 2. So let me just draw volume 2 here. So this is the original CAD model, and if we select it, it tells us that the geometry engine is ASIS, which is the CAD kernel behind Cubit. So yeah, so that's what we've done here. So this green surface is Cubit's interpretation of the STL file that can be remeshed, coarser, or finer if you want. While these triangles are just the direct STL file.
That's great. Just a couple of the comments and we'll have you move on, Greg. So did unchecking the feature angle option ask Cubit to honor the finer features?
No, it didn't. It just took the default, which was 135. If we didn't want it to respect the features, well, I guess one thing is you'll want to have at least one curve, because the meshing algorithms that we license and that we use in Cubit, they all require at least one curve to kind of start the meshing. So it meshes a curve and then it meshes the surface around it. So it is useful to have at least one curve in your model. But there are cases where you may not have any curves. So there's this example that we ship with the example models with Cubit called the Eros asteroid. And I believe this will come in without any feature curves. So here there are no curves. And so it may be difficult to build a mesh for this model. It looks like actually our tri-mesh will actually build this mesh here. So that's actually really good. I was just kind of curious if it would mesh it. So that's good. So yeah, I guess it would be interesting to see if we could import the heart model without any curves at all. My guess would be just that we would set higher and higher feature angles, possibly. Yeah, but yeah, so it's just something to be aware of, I guess.
Great. Okay, thanks. Go ahead and move on, Greg.
Yeah, so there's a couple other kind of useful things that even I've discovered a few of them just in the last few months or so, and I wish I'd known about them for like the last 8 years. But there's just a lot in Cubit. So let me open up a model here, a different model on a different screen. So let's say that we've got this is a model of a gear. or of like a watch assembly, I'm going to just work on a single gear in here. So let's draw this volume. That's volume 25. So I'm just going to say delete volume all except volume 25. This is extended booleans that allow us to kind of dictate what we want to delete here or keep. Let's go ahead and compress this. So this is a hex meshable volume. It's sweepable from the top surface to the bottom. And so this should automatically mesh for us. But something that you might have noticed is that with kind of this uniform mesh size, these teeth maybe aren't really being represented very well by a single hex and a point on this hex. And so as I mentioned earlier, there's a whole bunch of options underneath this initial command called set. If we hit the question mark, we'll see all these print out. And this surface meshing scheme that was applied here is called paving, which is a workhorse in Cubit. I'm going to delete mesh here real quick, just so we can show this. So under the mesh mode, surface mode, and then schemes mode, we can select pave on a surface. And so there are some options here. Like there's paver cleanup, for instance, which we'll see is there's a set paver cleanup here. But there's some other options as well, like a minimum paver size and a maximum paver size. But there's also something that's not set underneath these pavers is one that's called, set maximum arc span. And so it accepts in a value in angles, so maybe like 5, to try to mesh arcs with a 5-degree span on this arc. So if we now remesh this top surface, we have to have probably a little bit smaller element size too. Just so it's at least close. So if we set this volume size, so we need to set this just here to see what my previous size was, like 0.2. Might set this to like 0.05. So then Cubit will try to respect that maximum arc span on your volume. And it'll try to respect that within the paver set limits that we had. So there's, anyway, so it's still, I guess this is a really high curvature model, but anyway, this is just this set paver. We probably just need to set some limit size changes as well. But it's just useful. So I made at one point, there's like a simpler example to demonstrate this on. Let's just do a brick and then extract out a cylinder from this brick. Ball too. Just to show this, if we set the so set maximum arc span default. So the default is essentially 400 degrees, so it's not to respect arcs at all. If we mesh this volume, then we can actually, so it's just taking the default mesh size here. If we set a finer size for the arc span, so maybe take this, again, this default size to say 10 degrees, and then remesh this volume. You might be able to see that Cubit is, between those two meshes, is trying to now respect that 10-degree arc span. And if we delete the mesh again and set the arc span to say 2.5 and mesh the volume, it's giving me a finer mesh along these curves. That's something that I just has found has been useful for trying to make sure that you capture curvature on parts, is by setting this maximum arc span. And so that's kind of a useful thing. Another really cool option is if you have a part, so like this knuckle part again, that by default, Cubit will try, if we were just to say mesh volume 1, Cubit will automatically try to build a hex mesh on this volume. And so it'll say that it's, in this case, it's failed because it can't figure out how to mesh this entire volume all at once. But if you're working with codes that say you don't need a hex mesh for, so maybe you're just doing like thermal analysis or vibration analysis, and you just need to build tetrahedral meshes. Well, let me silence me here. Is you can actually set the default meshing elements to triangles and tets. And so let me clear my screen here. So if I do set default element, you could choose to have tri and tet, or you can see here in all caps that quad and hexes are the default. So we can set default element tri tet. And then for the rest of the session here, if we just say mesh vol 1, it'll automatically set tet meshing as the element type. And so if you've got large assemblies of a lot of parts and you just need to build tet meshes, and if that's what you're going to be working on, this is a really useful setting to set in Cubit, just so that you don't have to do all these extra commands to turn all these volumes to tet meshes. Well, that's kind of a cool little feature there. So are there any other questions for us to answer, Matt, or should I move on?
Yeah, there may be one that comes in a minute, but why don't you go ahead and move on? Let's see if there's any to come in.
Sure. So something else. So as we've seen, as we're doing commands here, we're getting a lot of output to the screen, and especially when you're, say, doing like running scripts, you may not want to spend the time printing out all of these things to the screen. They're just going to fly past anyways, because they're maybe automated. Printing things to a screen takes time, and so it can slow down some of your scripts. And so there are some commands for turning off. You see here, like this is echoed the command that we'd run. So we ran mesh volume 1, so we echoed that command, and we've printed out information. And so there is a set of commands that can be useful for these sorts of cases where you don't want this information. So one is to set echo to be off. So set echo, and it can be either on or off. So we'll do off. And so now you can see if I do delete mesh, it just won't tell me this finish command part. So if I do mesh vol 1, it'll still print out the info, but it's not echoing my command, right? So there's no finish command information here. We can also, if you don't want to have warnings, you can set warnings to be off. And also Cubit is in the background, it is building a journal file. And so these journal files here have been created from these 3 Cubit sessions I have open. So if we like open up one of these journal files, here, this one will open for us.
So Greg, while you're opening that, there's a question if you can create a finer boundary mesh for a TEP mesh.
Yeah, I think I understand that question.
I assume that means the surface mesh, triangle mesh.
Yeah. So I think that's what I think is meant. So yeah, let me finish this thought and then we'll get to that. So if I look at like a journal file, Cubit's been, journaling all of these commands I've been running. I default to printing them out in Python form, but even this could take time that we're trying to write things to a text file, and especially if you're writing like over a network directory, that could take some time. So we can also set the journal to be off if we want. And that'll turn off the journaling. And then lastly, we're still getting out all this information. So we can set info to be off. And you get one last little information message and then it doesn't give you any more. And so now as I type stuff like, mesh vol 1, there's nothing is printed to the screen. So I've kind of turned off all of those printing to screen things, but it's really useful to put these commands in the top of like a journal file. So it's like set, echo off, info off, set journal off, and warning off. I throw these at the top of a lot of my scripts just so they can minimize. Like, I know what's going to happen. I don't need to see all this stuff getting printed out, and I can save you a little bit of time. So, yeah. So now what I'm going to do is now I'm going to turn these back on, so I can just set info on, and set echo on, set warning on, set journal on. Yeah, so on that question of the triangle meshes, we could set them to be finer. So if we, it's pretty easy to show on the knuckle geometry again. But I'll show it on the Eros model, on the asteroid. Let's import this asteroid model, and let's make the elements. Let's see the original tessellation that comes in.
Yes, so Greg, sorry, it looks like a clarification. The finer mesh is for like a boundary layer.
I don't believe we do boundary layers with TETs. Mark can maybe correct me if I'm wrong on that. One option we do have that can be useful for like thin regions, which in my former job we did a lot when we would work with blown foam modeling or for plastic molding. There is an option to tap measure just to, let's see, I need a good model for this. Let's do 3x1. Let's make a couple really thin slices here. Like 0.9. So if I, here we go. Delete vol 2, 3. And let's create one more of those. Move vol to z.1. Maybe 5. So if I subtract volumes 2 and 3 from volume 1, so this geometry now has two voids inside and a kind of a solid through the middle. We clip this. Be able to see this a little clearer, maybe. So there's this little thin gap here in our model. And what we can do in Cubit in our tet mesher, it's not quite boundary layers, but there is this this ability to set minimum tet layers, say to 3, and that will enforce that through these thin regions, you have a certain amount of tetrahedra included. So I'm going to set this minimum. So if I don't set this minimum, maybe we'll do that one first. So you'll see that Cubit here has just put in a single layer of tetrahedra through this region. But if I know that for my blown foam modeling or for my plastic injection stuff that I need to have, say, 3 elements through a thickness to get good results, we can mesh this with the minimum tet layers to stay set at 3. And so let's set this volume 1 scheme tet mesh proximity layers on and then value to 3. And then Cubit will build us this mesh here. Refresh display, and so yeah, what we can see is the draw tet all. Cubits at least try to give us a certain amount of elements through the thickness. So not quite boundary layers, but I know in my former job when we would do models of casting or blown foams and plastic injection, that this was a tool that we used a lot just to capture tetrahedra in thin regions.
Yeah, just as a note, boundary layers is something that we're continually evaluating if we want to make some investments there. So if that is something that you would use, I'd like to hear it. So
yeah.
Okay, Greg, just a time check. It looks like we've got just a few minutes left. Did you want to move into the command line options or?
So I've already been showing some of those command line options. One other option though that is really useful, but also is one to be a little careful with, is show this geometry here, is the graphics rendering. If we do, so there's this option called graphics tolerance, and allows you to choose like an angle for your render facets. So sometimes what happens is you're looking somewhere close on a model, and you're maybe trying to determine whether or not like, does this curve, is it tangent at this location, or is it really kind of come in, and is there an angle here? And so you can kind of see the render facets in the geometry right now. And so you might want to set your graphics tolerance. The default is 15 degrees. So you might want to set it to 5. And you can see that we've updated the graphics. So it's now clear to see these curves. We might even want, the finest we can go is 1. That'll let you to get really smooth surfaces and curves if you're really trying to do some detailed inspection. But it does take longer to render, obviously, because it's a global parameter. So everything is globally rendered with a 1 degree facet. And so sometimes what I also will do is, just for speed, is I might set the graphics angle tolerance or tolerance angle to 45 degrees. So it's very coarse. And so I'll do this for scripts where I just want it to blow through my model quickly. And I don't really want to spend time rendering because I don't need it. And then at the end, I'll come through and then reset the default back to 15 or so. So anyway, that's just another really useful command line option. It is accessible through the tools options to set the angle to something like the 15, but there's just a lot of clicking I find. So I oftentimes will just in the middle of going through things, I'll just be setting graphics tolerance from the command line. So yeah, there was less of those I wanted to share. So are there any last minute questions, Matt, for us to answer?
Yeah, looks like there's just a few more coming in. And by the way, thank you, Greg, for the more intermediate and expert level guidance today. It's fun to have webinars that go beyond the getting started. So Thanks for all you prepared. So here's a question from Pirka. Is there a tool for recombining tri-meshes with quad meshes? For example, the asteroids model tri-mesh looked like it could be recombined from tris to quads in some areas.
Yeah, so we don't do recombining. So like tri to quad. So what's being asked here is you can see how these are two triangles that can be joined across the split edge. And so you can, so there are some facet modelers that will kind of identify those and join those together. But what we can do in Cubit is you can actually just remesh with quads. Now the quad mesher does require to have a split. It has to have at least one curve. So what we can actually do here is cut this surface, say like by a coordinate plane. So we just like cut it in half here. Oops, we need to cut on. This is another command that's useful too. Sometimes you'll see that there's a command that's a developer command. And so it'll tell you to set developer commands to on. So we'll go ahead and just copy and paste that. So now I've got at least a curve that bounds my surface. And from here, we could then just use so mesh mode, surface, scheme, pave. And we could pave mesh these two surfaces with quads. And I haven't imprinted these models. We talked about imprinting in previous webinars, but that's what we need to do here is imprint and merge. We need to have a tolerant imprint is my guess, by the way. So it's like 20 minus 2 or something. Yeah, and then I think mesh surfall. I need it a little bit coarser still. So this is how we do quad kind of remeshing in Cubit, is just to use our built-in like paver on the surfaces that you have. So is that helpful guidance? It's fitting then these quads are then being projected to the input triangulation that we'd had. And so we could even set this to be like an even finer mesh. So what's the current mesh size is like 1, so we could set surf all size 0.25, mesh surf 6, and mesh just even finer on that surface.
That's helpful. Thanks, Greg.
Hmm.
Okay, we'll just leave it open for another few seconds if there's any other questions that are going to come in. Otherwise, we've had a few queries. This webinar is being recorded, and you'll get a link to it after it's posted online. So, and again, as you have more questions that come up in the future, you're welcome to put them on the Coreform website in the form. We'll have answering questions there, so that way everyone can benefit from the answers. Okay, looks like here's one. Maybe this may be the last question of the day from Ron. Okay. What's the best way to propagate a TET mesh?
Yeah, so I guess the question I'd have is what specifically is meant by TET meshing. I'll maybe give an example based on what I think is meant, but if Ron, if you can maybe clarify that for us or for me a little bit. So I think what you're asking is, say that we had, so let's actually, do I still have the, let's import this, this watch geometry that we had. I think what you're asking is, how do I propagate like a TET mesh from one volume to another?
Yeah, so here's a clarification from Ron. for an organic shape where the smaller details need finer meshes than the larger features. Like how to control that.
Yeah. So in Cubit, if we import, let's just re-import that heart model again. Just as maybe for time, we'll just do the asteroid model. So there are in the TEP mesher, you can specify on surfaces like a deviation angle. So you could say that you want like 5-degree deviation angle. So you can kind of see that's going to try to capture these divots a little bit more accurately. But also there's this geometry sizing, and you can specify like surface gradation. And so that tells you how quickly are triangles allowed to grow. And so 1.3 is maybe they allow to grow fairly quickly. Other meshing tools will sometimes use 1.05 as the gradation, as I know is another common setting. So that's kind of how you can control how quickly, so you can see here by setting this 1.05, we've tried to refine these divots a bit more accurately, and then they've grown kind of slowly outwards. If we set this back to say 1.3, we should see this grow much quicker. So you see how much quicker those elements grew because of this gradation set to 1.3. So that's how you can kind of control how quickly they propagate from small to large. Does that answer your question, Ron? Yeah. So I think that does answer the question. But that's just a really good way. By having a larger gradation, you will sacrifice some element quality at the expense of, I want to have fewer tets. So typically the smaller the gradation is, the higher quality tets there might be. But we also then still have these options to try to say minimize sliver tets, minimize over-constrained elements as well. And you can set these to different, like how much time do you want to spend optimizing that mesh. So that can be a way to still have a high gradation, but then recover a high quality tet mesh. So
that's great. Yeah, Ron said that was a good answer for him.
Good.
So yeah, so thanks everyone for coming. This is the first webinar that we've done like this that's been a little bit more advanced, more of a kind of an open Q&A session. We're always interested in your feedback. We don't have a poll set up at the end of this webinar, but if you go to our forum afterwards and just weigh in and let us know if you like this format, if you'd like to see more of this, if you have any suggestions, we'd appreciate that. So with that, have a great day. Thanks, everyone.
Thanks, everyone.